Okay, number theory. Well, this chapter is a part of your reading homework. Well, it covers how to add two negative numbers or how to add a negative number to a positive number, how to add fractions. So, these are the stuff that you're supposed to know. So, I leave it to you. I just cover very, very important points of this chapter in this lecture. Okay. So, one thing, you know, in that chapter is about square root. Well, for example, we have a square root of 36. So, we know that square root of 36 is like, you know, it's perfect square. So the answer is 6 because we know that 6 times 6 actually gives you 36. Or when we have a square root of 81, the answer is 9 because 9 multiplied by 9 gives you 81. So these are perfect squares that we have. So, you know, when we have a square root of 36, it gives you 6. Square root of 81 gives you 9. These are, whole numbers, right? Not all the square roots are, you know, like that. So, 36, 81, we call them, perfect squares. So a perfect square is a number that is the square of a whole number, right? But it's not always the case, right? For example, we can have a square root of 3. Okay. Well, let's say, we have a situation that you have, square root in denominator and you don't want to have, square root in denominator. So, well, you want to get rid of the square root in denominator. So here is the strategy. For example, you have 1 over square root of 3. You want to get rid of the square root in denominator, so you multiply denominator and numerator both by square root. Okay, numerator 1 times the square root of 3 is the square root of 3, and denominator square root of 3 times the square root of 3. 3 times 3 is 9, so it's the square root of 9. So square root of 9 is 3, and numerator you have a square root of 3. So here we go. So you got rid of the square root that you had in denominator, right? So 1 over square root of 3, then it's equal to square root of 3 over 3. So rationalizing denominator. That's the process. Here we go. So, or for example, you have 1 over square root of 5. You want to get rid of the square root that you have in denominator. So what you do, you multiply both numerator and denominator by square root of 5. Numerator 1 times the square root of 5 is the square root of 5. Denominator square root of 5 times the square root of 5 is the square root of 5 times 5 is 25. So numerator is the square root of 5. Denominator square root of 25 is 5. Here we go. So 1 over square root of 5 is equal to square root of 5 over 5. You got rid of the square root that you had in denominator. Okay. So the set of rational numbers consists of all the numbers that can be expressed as a quotient of two integers while denominator is not 0, okay, like 1 over 2 or minus 3 over 4 or 5, which is 5 over 1 or 0, right? So it's like a over b. A and b are integers, okay? So, well, when you have a rational number a over b, you can express it as a decimal by dividing by dividing the denominator b, okay, into the numerator a. So a over b is a divided by b, right? So for example, you have 5 over 8 or 7 over 11. Well, let's try. Use your calculator. 5 over 8. 5 divided by 8 is 0.625. And 7 over 11 It's actually 0.636363. Well, 63 is repeating. Okay, so 5 over 8, you have 0.625 is terminating decimal. The decimal ends, right? But when you divide 7 by 11, right, you get 0.636363. So 63 is repeating. So we call that a repeating decimal. Okay, how can we actually express a repeating decimal in A over B form? Okay, there are some steps that we need to follow. Okay, first of all, step 1. When you are given a repeating decimal like here, 0.6666 is repeating, okay? Well, call this repeating decimal n. Okay, so we say that n is equal to 0.66666, okay? Now step 2. If there is one repeating digit, multiply both sides of the equation in step 1 by 10. If you have two repeating digits, we multiply both sides of the equation in step 1 by 100. If we have three repeating digits, then we multiply both sides of the equation in step 1 by 1000. Okay, now look at here. N is 0.6666. Only one digit, which is 6, is repeating, right? So in step 2, we multiply both sides of the equation in step 1 by 10. So n is equal to 0.666, so on. So one digit is repeating, so we multiply both sides of this equation by 10. So 10 times n is equal to, right side, when you multiply by 10, you get 6.666, like that. Okay. Now step 3, subtract the equation in the step 1 from the equation in step 2. Make sure that you line up the decimal points before subtracting. Sure. So we have 10n is equal to 6.666, like that. And we have n is equal to 0.666, so on. We subtract. When we subtract the left side separately, and we subtract the right side separately. Okay, on the left side, 10n minus 1n is 9n. And on the right side, please make sure that the decimal points are aligned. 6.666 minus 0.666 is 6. Now, solve this equation for n. 9n is equal to 6. You want to find n. So step 4, so we have 9n is equal to 6. Step 4, you solve it for n. Divide both sides of the equation in step 3 by the number in front of n and solve for n. Okay, so we have 9n is equal to 6. Divide both sides of this equation by 9. On the left side, 9 and 9 cancel each other. So what we have, then n is equal to 6 over 9. If you can simplify that, do it. So, well, I can divide both numerator and denominator by 3. So n is equal to then 2 over 3, right? Because 6 is 2 times 3. And 9 is 3 times 3. 3 and 3 cancel each other, so n is 2 over 3. Well, you can test it. Use your calculator. 2 divided by 3 is actually 0.66666. Is repeating, so the answer is right. Okay, so you had a repeating decimal. You changed that into a ratio. You changed that, to A over B form, right? Here we go. So these are the steps that we follow. Let n equal the repeating decimal. Then multiply both sides of the equation in step 1 by 10 if one digit repeats, by 100 if two digits repeat, by 1000 if three digits repeat, and so on. Step 3, subtract the equation in step 1 from the equation in step 2. Step 4, divide both sides of the equation in step 3 by the number in front of n and solve for n. Okay, let's say we have, two repeating digits, 5 and 8. Guys, this bar that you see means that, it's on top of the actually digits that are repeating, okay? For example, here we have 0.58, 58, 58, 58, 58 are two digits that repeat. So we can write it down as 0.58 and we put a bar on top of the digits that are repeating, okay? So we want to express 0.585858 as a quotient of integers, okay? Step 1, I call it n, okay? So n is equal to 0.585858, so on. Now step 2. How many digits are repeating? 2 digits. Because there are 2 repeating digits, so I multiply both sides of the equation in step 1 by 100. Okay, so n is equal to 0.5858, so multiply that by 100. 100 times n is equal to, okay, right side, when you multiply that by 100, you get 58.5858 and so on. Okay, step 3, you subtract the equations. Okay, so we have 100n, which is equal to 58.585858 and so on, and we have n, which is equal to 0.585858, so on. So when you subtract, we subtract the left side separately, so 100n minus 1n is 99n, and on the right side, well, make sure that these decimal points are aligned so you don't make any mistake in subtracting. 58.585858 minus 0.585858 is 58. Now we have 99n is equal to 58. We solve it for n, so we divide both sides of this equation by the number in front of n, which is 99. So we have 99n is equal to 58. Okay, so I divide both sides of this equation by 99. On the left side, 99 and 99 cancel each other, so n is equal to 58 over 99. You can try it actually. 58 divided by 99. Okay, you get 0.58585858 is repeating, so the answer is right. Okay, what about this case? Okay, it wants you to actually express 0.0, then 585858, so on. You want to express this as quotient of integers. Guys, but be careful. Before repeating numbers, we have a 0. What should I do? Well, I call this n, just like before. So n is 0.0585858, like that. But now, because we have a 0 before repeating decimals, okay, repeating digits, so what should I do? I have 1 0. I multiply both sides of the equation by 10 to get rid of this 0. Okay, on the left side, n multiplied by 10 is 10n. On the right side, I get rid of the 0, so I have 0.585858. Now it's like before. Now I move to step 2. If there are 2 repeating digits, multiply both sides of the equation by 100. Yeah, I have 2 repeating digits now. So my equation is 10n is equal to 0.585858. So I multiply, left side, okay, 10n is equal to, I'm gonna write it down again, 585858. I multiply left side by 100 because I have two digits that are repeating, and I multiply the right side by 100 too. Okay, on the left side, 100 times 10n is 1000n. On the right side, 0.585858 multiplied by 100 gives you 58.585858, like that. Now I subtract these two equations. So I have 1000n is equal to 58.5858, like that, and the equation 10n is equal to 0.5858. Okay, I subtract the left side separately. 1000n minus 10n, it's 990n. And on the right side, 58.5858 minus 0.5858 gives you 58. Now we have this equation. I solve it for n. So I have 990n is equal to 58. I want to solve it for n, so I divide both sides of this equation by 990. On the left side, 990 and 990 cancel each other, so n is equal to 58 over 990. You can try it. Just divide 58 by 990. Yeah, what I get is 0.0585858, like that. So here we go. Okay, what about irrational numbers? The set of irrational numbers is the set of numbers whose decimal representations are neither terminating or repeating. Well, they never end. Okay, like square root of 2. Okay, the decimal digits are not terminating, the decimal digits are not repeating, so decimal representation does not come to an end and doesn't have a block of repeating digit, right? It doesn't end. So square root of 2 is an example of an irrational number. Okay, well, for example, if I say square root of 2, 1.414214, it's just an, approximation because it has a decimal that never ends. Okay, well, the best known irrational number is pi, right? So in the calculations, usually we go with 3.14, but it's just an, approximation. Okay, it's an irrational number. So the decimal digits, the digits, are not repeating, they don't end, right? So they're not repeating, they're not terminating. So here we go. We have an irrational number. So as I said, I leave this chapter to you to study. So I just covered the important, points. Let me know if you have any question, okay? And don't forget to work on online activities related to this topic.